Selamat pagi! That means good morning in Bahasa Indonesia. Today we're going to be doing 10.5 tangents, part 1. Now, the first thing that you have to know about this, and this is very, very important, this tangent that we're going to do in this section has nothing to do with the other tangent that we learned about. So when we learned about sine, cosine tangent, that tangent is completely different than this tangent. Kind of like, you know the word to. It could mean like I have 2 dogs or something, or it could mean I'm going to the store. So it has a completely different meaning even though it's the same word. Well, this is the same thing. So it's the same word, it's tangent, but it has a completely different meaning. It does not mean opposite over adjacent in a right triangle. It does not mean that. So first we need to learn, well, what does tangent mean in this context? In this context, a tangent is a line. It's going to be a line, or I guess it could be a line segment, but it's going to be a line, and it has to be in the same plane as a circle, and it intersects the circle in exactly 1 point. Not 2 points, not like this line that I'm going to draw right here. That intersects the circle in 2 points, and if you only took part of that line, then it could be a chord of the circle, so that's not a tangent. A tangent has to intersect the circle in exactly 1 point. Like the red line there, that's an example of what a tangent looks like. So that is a tangent. A tangent is a line, intersects a circle in exactly 1 point. It intersects the circle at the point of tangency. So point A is called the point of tangency. And there's one last vocab word for us to take a look at. Here it is. A common tangent is going to be a line or a ray or a segment that is tangent to 2 circles in the same plane. So these pictures here are 2 different examples, but there's lots of other examples where you have 2 circles and then they share a common tangent. If I asked how many lines could I draw that are tangent to F, oh, well, there's an infinite number of lines that could be tangent to F. This line is tangent to F, this line is tangent to F, this line is tangent to F. All these different lines could be tangent to F, but how many lines could be tangent to both F and G? Those are going to be common tangents, and that's what we're going to practice in the first example. We're going to practice taking a look at pictures of 2 circles and drawing all of the different possible common tangents that we see. So in this first picture here on the left, they already drew 1 common tangent. Can you find another one? Another one would be if I went the opposite way like this. That would be another common tangent of those circles. And then the one on the right, they already have 1 there. Are there any other possible common tangents? We're actually going to do an example problem that's very similar to this. So let's go ahead and take a look at these example problems where we are trying to identify common tangents. All right, here's the first 2. I'm going to go ahead and do these for us so that you can kind of get used to it and see some examples. So in the picture on top, a common tangent that I see would be right here. It's a line and it touches both circles in exactly 1 point. And then also on the bottom, that would be another common tangent. Those are the only 2 common tangents that I see. All right, and then in the bottom, we kind of did an example like this already, but this one could be a common tangent. I didn't draw that perfectly, but. And then this one could be another common tangent. There's actually 2 more common tangents in the bottom. Can you see where they are? I'll give you a hint. Look at the picture on the top. So one of the other common tangents is going to be right here, and the other common tangent is going to be right here. So it's kind of tricky, and there's not really a specific way that you can know how many there are or what they will look like. You just kind of have to look at the picture and use your imagination to put lines in different places and see where you can find lines that are going to intersect both circles in exactly 1 point. So these are a few examples that we did together. Here's some for you to try on your own. Go ahead and pause the video and do your best to duplicate these circles on your notebook paper or on Notability. And after you have duplicated the pictures, then see if you can identify the common tangents in each one of these different examples. All right, these are the answers for you guys to check. Okay, so now that you know what a tangent is and you've had some practice drawing tangents, now we're going to learn a theorem about tangents. This is the only theorem that we're going to do today, and it says in a plane, a line is tangent to a circle if and only if it's perpendicular to a radius. If you were to draw a radius from the center of the circle to the tangent line, then it would be perpendicular. So that is a theorem. We're going to use this theorem to solve some problems. In this problem, they want us to determine if KL is a tangent line. So we have KL here, and the question is it tangent? Is it not tangent? You can't say yes or no just by looking at the picture. You have to be able to determine for sure. Well, according to the theorem, I know that if it's perpendicular, then it has to be a tangent. Well, how could I figure out if it's perpendicular? Well, if it's a right triangle, then it would be perpendicular. How can I figure out if it's a right triangle? I could use the Pythagorean theorem, a squared plus b squared equals c squared. If that works and if that's true, then it's a right triangle. A is going to be 15. B is going to be 8. What's the hypotenuse? It's not 9. 9 is only from K to here. So from here to J would be 8 because it's a radius and all radius are the same length. So the hypotenuse is going to be 9 plus 8, which is going to be 17. So now I'm going to use my calculator and I'm going to figure out if this is in fact going to be equal. All right, it looks like it is. It looks like 289 equals 289. That means that yes, this is a right triangle, therefore it's perpendicular, therefore the line is tangent. So my answer is going to be yes, the line KL is tangent. Here's one of these problems for you to try. Go ahead and copy this problem down into your notes, give it a try, then you can watch the video for the answer. And the answer is no, this line is not tangent to the circle. You can't say yes just because it looks like it is. It's actually not perpendicular. And I know that because I used the Pythagorean theorem and it did not end up working. The hypotenuse is 18 because we're adding 6, which is the radius, to 12. And so I said 6 squared plus 8 squared is 18 squared. Did not end up working. So the answer is no, it's not tangent. Now, I didn't actually have to do this entire thing right here because what do you know about 6 and 8? It is a Pythagorean triple. Remember, a Pythagorean triple is like 3, 4, 5. It's numbers that you automatically know are going to be correct for a right triangle. So in a right triangle, if one of the legs is 3 and the other leg is 4, and you know that it's a right triangle, you can automatically tell that the hypotenuse is going to be 5. This is the most popular Pythagorean triple. This is the one I said you guys have to memorize. There's lots of other Pythagorean triples too, but you don't have to know all of them, but you do have to know the 3, 4, 5. Well, 6, 8, and 10 is another Pythagorean triple if you just multiply all of those numbers by 2. So because I already know that 6 and 8 are part of a Pythagorean triple, I know that the hypotenuse would have to equal 10. So as soon as I added the 12 and the 6 together and it did not equal 10, I could automatically just skip all the work and just say, nope, it's not tangent because I know that Pythagorean triple and that does not work. So just a little shortcut for you. All right, we've got one more example problem. Here it is. This problem here says that JH is in fact tangent. So because they're telling us it is tangent, we know that it's 90 degrees. We know it's a right triangle. And now they want us to find the value of x. We can still use the Pythagorean theorem to find the value of x. We can say x squared plus 12 squared is equal to x plus 8 squared. We're going to be using some Algebra 1, which is good. You guys need to review Algebra 1 because you're going to be in Algebra 2 next year. Okay, so then we're going to say x squared plus 144 is equal to, do you remember how to simplify these? You can FOIL to go the long way. It'd be x plus 8, because that's what x plus 8 squared is. And then to FOIL, you multiply the first term, the outside term, the inside term, and the last term. So first is x and x, giving us x squared. Then it's x and 8. If you multiply those, it's 8x. Inside, 8 times x, also 8x. And the last terms are 8 and 8, which is 64. All right, now we have to continue to simplify this. I notice that there's an x squared on both sides, so I can start by subtracting x squared. Both of those are going to cancel, which is really nice. It's going to make our job a lot easier. 144 is going to equal, let me go ahead and combine these now, 16x plus 64. I'm going to subtract 64 on both sides, and I get 80 is equal to 16x, and then I can divide by 16, and I get that x is equal to 5. Now they wanted us to find x. Perfect. Okay, so x is equal to 5. That is our final answer. Okay, I'm going to ask you guys to try 2 of these problems on your own. So here they are. Go ahead and pause the video, give these 2 problems a try, and then you can watch for the answer. And these are the last 2 problems in the whole video today, so go ahead and take your time on them. All right, so this first problem here is definitely the easier one to do. We would do x squared plus 14 squared is equal to 17 squared. And then we would do x squared plus 196 equals 289. And then we're going to subtract 196 on both sides. And we get 93. So x squared is 93. And then we have to take the square root of 93. And it's okay to use a decimal for this one. So we're just going to say 9.6. I'll just round it to that. Doesn't matter what you round it to for this problem. So x is equal to 9.6. All right, now for part B, this one's a little bit more difficult, but still solvable. First, we need to figure out how to label QR. Should I label it with an X, a Y? How do I know what to label it as? QR is a radius, and R, they didn't give us a point for here, so let me just put a T. RT is also a radius. What do you know about radius in a circle? They're always the same thing as each other. So if RT is equal to X, then RQ has to also be equal to X. It's important that you label those with the same variable. All right, now let's set our problem up using the Pythagorean theorem. X squared plus 4 squared is going to equal the hypotenuse squared. The hypotenuse is x plus 2. So x squared plus 16 is equal to x plus 2 times x plus 2. Now we're going to use FOIL here. We're going to multiply the first terms together. The x is our first, so x times x is x squared. Next, it's the outside terms. The x and the 2 are on the outside, so that's going to become a 2x. Then the inside terms are also 2 and x. And then the last terms are 2 and 2, which is 4. And then we can continue to simplify this. I notice there's an x squared on both sides, so I can subtract x squared, and those will end up canceling. I can also subtract 4 on both sides. So I will get 12 is equal to 4x when I combine those together. And then when I divide by 4, I get that x is equal to 3. All right, guys, that was it for today. Great job, great work. Go ahead and submit your notes to Canvas, and then you are done with this video. Bye!